Hello everyone. Myself Sumit Maheshwari, working in ABES Engineering College as an assistant professor. Today I'm delivering a lecture on three-phase AC system star connection, which is the topic of a subject fundamental of electrical engineering. So first of all, we are understanding few terms. What is star connection? What are the relationship between line voltages and phase voltages, line current and phase current? After that, we can discuss about the phasor diagram and three-phase power. Now, we have three phases R, Y, B in figure number 1. This is our figure number 1. If we have three-phase power and we are connected from one end of these three phases to the supply, and another end is joining together and put a name neutral point. So such type of connection is called star connection. So this is in figure number 2. The looks like of a star connection. Now we have three balance supply that is called VRN, VYN, and VBN, which is 120-degree apart and equal in magnitude is called VM. So in polar form, these three vectors are first VM angle 0 degree. Similarly, our yellow phase is called VM angle minus K 120 degree, and blue phase is called either VM angle minus K 240 in negative sequence, and in positive sequence it is called VM plus 120 degree. Now we can discuss about the relationship between line current and phase current. In R phase, current flowing from this neutral point to the end line, if we can write this current is I and R, and this current is IR. So these two currents are equal. Similarly, this IN, IYN, and IBN. These two currents also equal to the phase current IY and IB simultaneously. So these phase current and these line currents are equal. The currents INR, INY, and INB is called phase current, and the current which are reaching at the line RYB is called line current. So here in star connection, our line current is equal to phase current. Now we can talk about the phase voltages, line and phase voltages. So the voltage across a line and neutral is called phase voltage, and voltage between two lines is called line voltages. So this is our VP because it is voltage between one phase to the neutral. And if we are talking about this two phases, we are seeing this line voltages. Now, in our first relationship of these line and phase voltages, our VRN is VM angle 0 degree, and our VYN is VM angle minus 120 degree. So what our line voltages VL, VRY, this VRY. So this is our R point, this is our Y point, and this is our N point. So the voltage across VRY is VRN plus VNY, VRN plus VNY. We can write our second phasor with minus sign by reversing. Now put the values. PM angle 0 degree and VM angle minus K 120 degree. After solving this two vector quantities, we can write here the resultant VM 1.732 magnitude with an angle 30 degree. After calculating from the calculator, this is our first line voltage VRY. Similarly, we are talking about VYB, which is called VYN, VYN plus VNB. We are reversing the second vector, VBN. So what is the value of VYN? This is our VYN. 1 angle minus 120 degree minus what is the value of VBN? This is plus 120 degree. So 1 angle 120 degree. After calculating this term by using calculator, we can find 1.732 angle minus 90 degree. So this is our second line voltage VYB. Similarly, we are talking about our third phase VBR. So first of all, we are taking VBN and VNR. We are reversing the second vector, VBN minus VRN. So what is the value of VBN? This is plus 120 degree. taking common Vm, 1 angle 120 degree minus VRN, Vm angle 0 degree. So after calculating this term by using calculator, you are finding in polar form Vm 1.732 with an angle 150 degree. So we have three relationship of our voltages, line voltages. First, VRY, that is called Vm 1.732 angle 30 degree. VYB, Vm 1.732 angle minus 90 degree, and VBR, that is Vm 1.732 angle 150 degree. If we are taking the magnitude of these line voltages, VL, that is called root 3 times of Vm. And initially, we are taking three phase vector Vp having magnitude Vm. So if we are replacing our Vm with Vp, we are getting the relationship VL is equal to root 3 times of Vp. This is our voltage relationship. And initially, we are getting the line IL is equal to IP. So these are two relationship, line and phase voltages and current. So in this slide, we are discussing the phasor diagram of these line and phase quantities. These are our phase voltages, these three, and by taking two phase voltages, we are finding our line voltages in this red vector. This is our line voltages. So finally, we are getting VL is equal to root 3 times of Vp, and line current and phase current both are equal. Now we are talking about the power of star connection. In single phase, what is the power? For single phase power, active power, Vi cos phi. If we have three phases, so the active power is 3 times of all the three phases. So the power taken from phases to the resultant value is called 3 times of thrice of Vp Ip cos phi. And we know that our VL is equal to root 3 times of Vp. So put the value of Vp. It is called VL upon root 3. And what is the value of IP and IL? Both are equal. So in such a way, our line power, active power, is root 3 times of VLIL cos phi, or in phase term, this is thrice of VPIP cos phi. Similarly, what is our reactive power? Reactive power, that is thrice of VPIP sin phi, or root 3 times of VLIL sin phi. Similarly, our apparent power, that is thrice of VPIP in terms of phase quantities, and root 3 times of VLIL. So the unit of active power is in watt and reactive power is in volt ampere reactive, and our apparent power is in volt ampere. So in such a way, we are developing the relationship between line and phase quantities of voltages and current. In next lecture, we are talking about the similar relationship for delta connection. Our references, these are our disclaimer. Thank you.